Okay, guys, sorry for taking so long, and this is the part two of my lecture about the semiconductor materials, which is called EMC or epoxy molding compound. So, from part one, we have discussed the very basic information, and then I cited this page to discuss the common terms or frequently used terminologies in the technology material, which is called EMC or epoxy molding compound. So as part 2, I would like you guys to take a deeper understanding of much unusual terms that is being used in the semiconductor industry. So allow me to make my very best to explain in a layman's term as much as I can do and as much as possible. So here we go. So this page is showing you that the epoxy molding compound or EMC in terms of process. So upon the receipt of the semiconductor company who is ordering from the EMC supplier, the most common material in form are being supplied in terms of this pelletized form. It looks like a tablet. It looks like this shape of a cylindrical, but it's a solid form. This is coming from a powder that being compressed, compacted in order to make this shape. So this is very well compacted, as you can see on the picture. This is the compound, because as I've mentioned in the earlier discussion, compound means a combination of many materials that makes it a compound. So on the left corner is the process, the right side is the state of the resin, or the state of the EMC or the material. So the EMC, the tablets or pellets, basically it is uncured. In order to form this in the process of EMC, it is being undergone in terms of B stage. In the next episode that I'm going to share soon will be how to manufacture an epoxy molding compound. So I'm giving you a very brief information on the process flow, how to make EMC. But in this portion, I am just teaching how the very basic of using or the understanding of the EMC. So from this point, I'm just showing you that the molding compound or the compound which is uncured, is not fully reacted, are being softened. Means softened in terms of utilizing the high temperature. High temperature means during the encapsulation process you use around 175 or 180 degrees Celsius. So imagine it's very high compared to, for example, the boiling point of the water, which is just 100 degrees C. So I'm talking here almost like a double of that boiling point of the water. So the metal which is being heated at this temperature is very, very hot. So if you are using a personal protective equipment or PPE, then you should understand that there is a high risk of touching it by your bare hands, because it will give you a very severe concern about being burned. So from this state of the EMC tablet or pellets, it is being used in the process of encapsulation, as I have mentioned in the previous or the part 1 of this lecture. So upon placing the tablet or the pellet into the pot of a mold machine in the mold tool, it is being transferred or being filled up into the spaces or cold cavity, mold cavities, which is used to encapsulate the circuitry inside. So the plunger is being moved or displaced just to push the resin, which is currently melting, in order to flow and cure into the desired geometry where the packaging are being designed. So this is called transfer molding. So after you have completely filled up the cavity, it is become a molded package, and that does it looks like this kind of illustration on the screen. So now you have a cured resin. So since I have mentioned in the earlier teaching, this is we are talking about a thermoset resin. A thermoset resin, as I have recalled, is the type of plastic or the resin that are once melted and hardened, cured. When you apply heat, it will not be cured again. So that is a very different to the thermoplastic, which is once is a kind of plastic that once you apply heat, melt, and then you took it out from the heated temperature, and then try to cool it down and become hardened again. So once you heat again, apply heat again, it will melt again. So that's the difference between, as I mentioned earlier, between thermoset and a thermoplastic resin. All right. So come to the next page. So now I'm talking about how to judge whether the process are okay or acceptable. It goes with the form and fit function of the intended process. So early on I was discussing the very basic terminologies and the basic chemical or mechanical or technical information about the molding compound. So now I'm going to talk about the two things that are very important in terms of process. One is the moldability, the next is reliability. So these are the important properties. So in the moldability, you talk about the flowability. Flowability means how the melted resin are being flown or being or how it is flowing or filling the intended spaces to fill up the entire cavities, for example, of a package. So it's called flowability. And it talks about certain like spiral flow or fluidity or viscosity. These are the things that are being discussed about flowability. And then we talk about what is a suitable and proper curing time, because each of the material requires certain time in order to fully cure. Cure is being triggered in terms of temperature in the catalyst or hardener that are being used in order to react the components within it. Right? So it's called cure time, when you needed a time to fulfill the total reaction of the material of the chemical. Next is in terms of moldability, we also have this called void. Void is something like an empty space within. It's not fully filled, so it's called void. So, and then you have this kind of wire sweep. Wire sweep means from the two terms or two words. Wire means it's a connecting medium. Is a wire in terms of gold or aluminum or copper, which are being used nowadays to save cost from gold, because gold is very expensive. And the sweep means it's a movement of the wire from its original position, being swept away or moved to or displaced to a certain position or location because of the flowability, because of the force being applied into it. That's why it is being moved from its original space, original location. And then workability means in terms of manufacturability, in terms of continuous usage, then it's being used properly, no issues in terms of production. So it is called what's called workability. And then when you have fulfilled everything about moldability, you have this kind of what we call reliability. Do you know, guys, what's the meaning of reliability? Means from the root word reliable. Reliable means when you say reliable, even in your relationship, you say you are reliable. Things are becoming reliable, because reliability, it talks about time and the pressure or the stress being applied. So when a thing or when the material can stand the storm, can stand the stress, can stand the pressure within a specific longer time or a time being defined to set foot about the threshold or where it is to be considered finally that's reliable, That's what you called able to withstand things that are being applied on. So when the stress is applied, and the device or the package can withstand for a specific period of time, then you can tell that the package or the device is being reliable. So there are certain guidelines like a JEDEC or AEC standards, automotive standards, are being defined by many customers or players in the market about to define how reliable a device or a package is. So in terms of reliability, there's the few things that being measured. A few of the things that I have to mention here is like low ionic impurity. So low ionic impurity means impurity is from the root word pure. So when it's not pure, it's impure. So it means there are certain halogens or certain unwanted materials within the solutions. So the ionic is the ions that are not pure, which means it affects the purity of the material. So when you have the material that are not emitting impurities, then it's a good material. So this helps to become the material reliable. So this is some kind of unwanted thing that clouding or making an effect in the overall formulation of the material, right? So it's called low ionic impurity. And then you have this kind of CTE, or coefficient of thermal expansion. So when you have a proper CTE, then it matches with the different material interfaces. Sorry for the disruption of that movement, because I'm trying to set up my room to give you a better lecture about my advocacy. So I have just started this kind of thing, but I'm enjoying it. Right? So let me continue. So for proper TG means a glass transition. Like for example, you wanted to set it to more than 100 degrees Z because of different requirement for automotive or application in the general electronics. So sometimes TG play a role, especially for if you require a high voltage, high power packaging. So your EMC, your material, or the insulation material like EMC should withstand a high voltage or high power. Then you need somehow a high glass transition. So we will explain furthermore on this property in the next training or next lecture. And then of course some of the reliability concern requires a very good material that can withstand moisture. So it should have a very good moisture resistance, including the heat resistance. And of course, when you apply certain high temperature, high moisture, high pressure within the package, you also need to have a very good adhesion. It weakens the adhesions when you apply pressure. Something like you're clinging to something and there's pressure applied on you. So the worst thing that could happen is you take loose control of holding all the material. So in a simple manner, like in real life, when you're holding on something and there's pressure around you, you tends to give up and then unhold or remove your hand from holding things, right? So just like here, so material are connected to each other, but upon applying of this environmental or other pressure, the adhesion becomes weakened. So it is very good, important. It's a very good thing that to understand that adhesion is a very important thing in the packaging. So next is flammability. Flammability talks about the flame. There's a standard UL Underwriters Laboratory, which can Google or can check over internet. So flammability is some kind of ruling related to plastic. So when it's getting burned, overheated your material, it creates fire. There's a policy about flammability where you can define that the flame should stop from burning or from flaming. All right. So these are just few of the things about flammability. And then we talk about we come to a point that to understand as I've talked about compound, which is composition of several material. So an EMC is a composition of several things, or several materials. That's why it's called molding compound. So it's why compound, because epoxy, as I have mentioned earlier, is some kind of adhesive thing. So come to think about the layman's term, epoxy means a very sticky, adhering, and then compounds means combination of many materials, and then molding means you have to mold, you have to form, used to form a thing. So this is an EMC being applied for. So EMC, this kind of figure on the left side, come to think that, or imagine that it is one pellet, one tablet that I have shown earlier. So if you can see, majority of the composition is related to fused silica or a filler. By the way, when you say silica, what comes into your mind? Its scientific name is called silicon dioxide, SiO2, which is basically from the layman term, it came from the sand. So mining is stone, sand, and then processed it to make this spherical shapes over here on the right side. Then you will understand that after process, this simple earth material being processed or being used to certain application. This is what we call silica, or in the technical term is filler. And next majority of the material being used is resin. So in the resin, you have epoxy and the hardener, and the rest of the components are called others, which are mainly a portion of the ingredients in the making EMC. So these are like a catalyst called coupling agent, elastomer, flame retardant, wax, and a carbon. Carbon used to make the pigments or color it. So everybody say like, why is the epoxy molding on colored black? It's because of the colorant, which is called pigment or carbon black, right? So maybe maybe some of the terms here are not useful to you. So let me just explain a bit. So catalyst means is a precursor, is a tool to in order to engage things and then react. So catalyst is needed in order for epoxy and hardener to react, to blend. In order to react anything, then you needed the heat, for example. So these are very important chemicals or substance that are interacting with each other. Coupling agent is something like couple, means couple. It helps to combine or to couple things in the raw material. So it is an agent. It's just an additive that helps to react things, these raw materials within it, and help to flow, have a better flow of the chemical of the resin, right? Elastomer is elastomer means elastic, means some kind of polymer that used to make the EMC looks like elastic. So is a component to help the EMC not to be too sturdy, not too rigid. So it somehow help to loosen the material a bit when material be having exposed to certain stresses, right? And then flame retardant is a component that helps to retard, to stop the flame, or when the plastic is being burned. Then you have to ensure that it passes the flammability. Then flame retardant is one of the things being added to the composition. And next is a wax. So as I mentioned, wax is a releasing agent. It helps to loosen from the things from adhering to one surface. Too much wax, of course, is not so good in terms of EMC because it loses the adhesion. So, and it's without wax also is a bad thing because it makes very sticky material to the tooling, to the mold tool, things like that. So on the right side, you can see the cross-sectional view of accurate EMC. You can see those of pure silica, and in between are the resin matrix. So the resin helps to connect this silica together to make it is a compound to form as a solid material. So basically, you can think about and imagine that when you say EMC, epoxy molding compound, it is composed mainly by two materials which are called fused silica, the silica, and the resin, which are the hardener and epoxy. The rest are just special agent or ingredients in order to enhance the material quality, right? So for a few more slides, I'm giving you for this part 2 about the how do this raw material looks like. So if you're in the factory of epoxy molding compound, you will see a lot of raw materials that are being combined to make it a compound. So you can see fused silica, epoxy coupling agent, epoxy resin, the hardener, the wax, and the catalyst, elastomer, antimony, which is flame retardant, including the brominated epoxide, which is also an example of the flame retardant, and then carbon black or the pigment. And then you can see from all these raw materials, have you noticed that everything are solid except for the coupling agent? Yes, that's true. So because the supplier takes to get it from several suppliers as well. So the EMC supplier are buying the raw material from individual raw material supplier. So it's what you call like a business to business, a B2B. So usually the EMC supplier are the upstream, one of the upstream supply chain supplier. So once all these of the raw material are being mixed together, and then you have the mixture of raw material, it looks like a grayish ash thing, which is shown on the photo here. So, and then once you have mixed all this compound, and then you have the final mixture of the raw material, this is like it is called a dry mixing. Then once you do the kneading process, then you create this kind of EMC sheet after kneading. Kneading is what you call a blending of the raw material. So this comes in sheets because when you do knead, it creates friction, and the tool to use to knead are actually heated around 100 degrees C to initiate the initial reaction of this raw material being mixed together in order to homogenize the raw material. However, this is called the B stage, where you talk about preliminary reaction of the raw material. You don't have to apply too much heat because it will basically strengthen the reaction, which maybe you have a problem later when you apply it during the encapsulation process. All right. Then, just to recall and to conclude the part 2 of this training, so let's have a quick recall of the EMC material and its function. So let's say on the left column is the raw material or the raw materials, and then what its purpose or role in the packaging. So first is fused silica filler or filler. Basically, these are the solid thing. It doesn't melt, and then therefore it defines the mechanical property of the material. It helps to define the coefficient of thermal expansion, and more filler means less water absorption, because basically filler are not absorbing moisture at all. So it has a below basically below 0.1 or below 1% moisture absorption in the entire packaging in the material. So because it's sand, it's a silica, it's very solid, so it doesn't absorb moisture. Next is coupling agent. So coupling agent, as I mentioned earlier, it increases the adhesion, improve the flow of the compound. And then the resin, which are epoxy resin, hardener, these help to form a cured material. So these are the two materials that needed to help to bind together the silica, right? So because if you don't hardener, how come the resin becomes form into hardened type? So you need a hardener to basically hardened to make it solid, right? And then next is catalyst. Catalyst is to accelerate the curing reaction. High catalyst content means high curing reaction, right? High temperature means high accelerated curing rate. And then elastomer. Elastomer, as I mentioned, is something like a rubber, or you can the elasticity, elastic. You can name those very descriptive words. It helps to reduce the stress, and it makes low modules in the entire composite. And then flame retardant is it to remove or to is an anti-flame, so it is to stop the package from continuous burning, right? And then next is a wax releasing agent. It helps to release the adhesion. So too much wax is not also good, right? As I mentioned earlier. And then the last one is the carbon, which is as a concealment. It helps to color the compound. So somebody says that why EMC is called black, because black is in the electronic industry, in the very basic physics study, when you are listening to your teacher back in your physics class, they say, why are you wearing black, or why black is good in terms of thermal control. So endothermic and exothermic property of black, of the material, helps to redefine why black is very important in the electronics packaging. So endothermic means able to easy to absorb heat, and then endothermics are the process to release the heat. So means having it black when you are running an electrical component in the form of integrated circuit, it creates heat. So you need a black material in order to control thermal management, right? So thank you for listening. I'm your KPP Master, or Professor Bo, giving you this part 2 of the epoxy molding compound. Till the next time, see you and goodbye.